e raised to minus 2a here because we took it out. So let's just do that. E raised to minus 2a. So this is here done. See, 3 ones are 3. So I don't think so we need this. And 1 plus 0 is 1. And 1 into u is u. So u plus 3. Here we are. So we found this part derivative. Now we need this part derivative. By the way, we found d by ds s plus a, but still we would do it. D by ds s plus a is, I told you we can separate terms, like taking derivative of two functions added as a whole is equal to taking both the function derivative separately and adding them. So I would take d by ds of s plus dA by ds, and as you know, divided by or with respect to ds means derivative means I have to take derivative of s terms, and others are constants if alone, and coefficient if multiplied with x. So what I did here is, so this is a, and a is alone, and also it is not multiplied with s term, right? Multiplied with x, so same joint term because of multiplication, because multiplication joins terms, so it puts them in same term, so they are coefficient, they are like undetachable to each other. So yeah, so but a is alone here and it is other than x, so it is a constant. So derivative of constant is 0, I told ya, so this is 0, and this is 1. By the way, I showed you here because of this d by ds equal to 1, because nx raised to n minus 1 formula, dx raised to n formula is nx raised to n minus 1. So s raised to, like s is here, so s nothing is there means s raised to 1, because like x raised to 1 is x, because nothing is there, and you multiply x 1 times, because raised to shows how many times you multiply, and you multiply x 1 times to nothing, then you get x, right? So s raised so nx raised to n minus 1, so I take the power, see, nx raised to n minus 1, so n is the power here, so I take it in multiplication coefficient, and raised to n minus 1, so I reduce its power by 1, so I brought that 1 to coefficient and reduced its power by 1, which was s raised to 0 into 1, and anything into 1 is that itself, because adding like that into nothing one time, like multiplication says how many times you are adding something, and adding to nothing one time something is that itself, so it remains same. Anything into 1 is same itself, so 1 into s raised to 0 is s raised to 0, and anything raised to s raised to 0 or anything raised to 0 is 1, right? So so s raised to 0 is 1, so this is 1, told ya. So this term is 1, so what I would do is 1, and there is minus 1 by a here, so anything multiplied by 1 is itself, just now I told you, so it would be minus 1 by a, wait a second, minus 1 by a plus this whole stuff, and now I would just erase it if you have seen it, so now you would know it, right? Did you see this? Yes. Now we are out of this. Now there is, wait a second, I have to erase something. Yes. Now this is d by ds of 1 by s plus a. This is simple, so what I would do is I would take it d by ds of s plus a raised to minus 1. Why? Because x raised to 1 says, like this power says, times multiplied itself to itself. But, right, but when I put x raised to minus 1, which is opposite sign, minus is opposite sign, right? Sign, so it says opposite of multiplication, which is division. So it tells us how many times it divides to itself. So this term was divided 1 times. So raised to minus 1, opposite sign of multiplication. So instead of multiplied 1 times, it is divided 1 times. So it is raised to minus 1. So now what I would do is, as you would know, I gave you like, see, s plus a, this part is, let's say, a u equal to f of s. So this part. So we have d by ds of f of u, which is equal to u raised to minus 1. Now, what is this case? Like this is u, a function, a function of u is getting derivated, and u itself is a function of s, which we need to take derivative. So what is now happening is, raised to thing is also a function, operation or rule, and s plus a is also a function or rule. This is not s, it is instead s plus a, something done with a s, not only s. So what did I tell you about function in a function? This is function in a function. F of u, then u inside is also f of s is a function, and s is the thing we need. So what I do is, in function in a function is chain rule. Take outside derivative, then take inside derivative. Let's do this. First I would do is take outside is a u du by ds multiplied by this inside function. Let's open up. U raised to minus 1, by the way, this function was, right? Now s plus a, the inside function. Like what u is, we have to break that. Okay. U equal to f of s, right? Let's say f of s. F of s. Let's say f of u ds. Now this is equal to d u raised, so what is f of u? It is u raised to minus 1 by ds. And what is f of s? It is s plus a stuff, right? ds. And just previously I told you, wait a second, did I erase it? Okay. Okay, I would do it again. D by ds of s plus a is, I can actually two functions added derivative total all together is functions derivative separately and adding them. So this is d by ds of s plus dA by ds. So derivative with respect to s means s is derivative, other are coefficient if multiplied with s, constant if alone. So coefficient constant means alone. So now what I would do is ds by ds, I told you it is 1, so let's write it 1, and dA by ds is I told you, so ds by ds, I told you it is 1, and see here, so this is here, and dA by ds is dA by ds is I told you A is other than s, so other than s, no derivative, it is taken as coefficient and multiplied with s, constant f alone. Constant f alone. So this is other than s term and it is alone. dA, A is other than s term and alone, so it would be taken as constant, and derivative of constant is 0, I told you. So derivative of constant is 0. Okay, so this is 0, so this is 0, 1 plus 0 is 1, so 1 plus 0 is 1. So what I would do here is this would be 1 plus 0, this would be 1, told you I solved it here. And sorry for the background noise. So of du raised to minus 1 by ds, I would do this, u raised to minus 1. So u raised to minus 1 is this is the n, because this is raised to, sorry for the background noise. Maybe I would cover it in shorts. So thanks for watching, like, subscribe, see you next time. I guess I can't complete it now, something came up.